people who ask me to go over protecting group on nodes 24, right? Which specific parts does people who ask this? Sorry, I don't know. Okay.
Just like, what are the substrates that you want us to use? Or when we want to make a protecting group, what are the substrates that we use?
Okay, so the one that I showed is TBU, right?
Could you maybe give an example that's not the one that you already gave on this, so that maybe we have something else that we can compare to?
So you can also use this one if you want.
Can we use any ROH?
Basically, that's the case.
And
Okay.
It's ROH and then comma H plus.
Yeah, so this one.
And then to undo it, we use H3.
So yeah, when you want to undo it, it's H3O plus. That's it.
When do we know to use it?
When do you know to use it? When you want to, okay, this one, what it works is for protecting the ROH group. When you don't want this OH to react with something else. In my notes, this R has another BR. This R has another BR. When you don't want, you only want the BR to react. You don't want this OH to react. Then you protect this ROH group. So it's become BR. In my notes, it's become O. Okay, let's use this one, OCH3. Okay, now it's no longer OH group. Then the rest of the part is only going to react on this BR. So this is protecting, which means, okay, later we are going to give you OH back. It's just not now, because when you have OH group, like the one that I showed, it's going to react with Grignard. Then BR cannot form Grignard.
How does that CH3OH get deprotonated?
Gets protonated?
Gets deprotonated because you have it as an OCH3. So
Yeah.
Where did the H go that was on the OH?
Where's the H go?
Because you have CH3OH, right?
Yeah.
And then you have, on that molecule, you have CH3O. I'm confused as to what deprotonated that CH3OH.
It's not deprotonated. It's this one attacked here.
Mm-hmm.
Okay, so this CH2OH like this, and then it formed OCH3. This is hydrogen.
Yeah, that's what I'm asking. What happened to that hydrogen? How does it get deprotonated? That was what I was asking.
So you have CH3OH,
Just have another one.
and then do this.
So we don't need any particular solvent. That's kind of what I was asking.
Oh, yeah. The one that I write is exactly what you need to write. Okay. Are we good with this? Okay. So this one, the next step we did in my notes is doing magnesium to form RMGX. With the previous OH, it's going to just react with the OH itself. So that's why you need to protect that OH. Yes?
Can you use protecting groups just to make an ether? Like if you want?
Yeah, you can stay here if you want. That's it.
Okay.
But why do you make that ether? Usually you don't want this OH to react, so you make an ether.
Okay.
So where do we go from here to get the OH back? Once we finish the reaction.
Okay, you do everything else, and then you do H3O plus, and then okay, whatever that's the large things that you have already reacted, then you have the OH. Yeah.
Where's the BR?
BR was okay. Like here, the one I showed is you use BR to form gradient, and then you react with a aldehyde.
Yeah.
So now you only use the H3O plus to get the OH back after you form
I'm
other.
confused as to how that mechanism works. Like, how are you just using H3O plus to get that OH?
So it works the same way as R prime and acidic condition to form ROH and R prime OH. Isn't that something we write in the mechanism?
Oh yes, we write this.
I don't remember. That's why I'm asking you to please go over it.
We use the
Yeah.
nucleophilic acid,
So
right?
yeah, so yeah, non-nucleophilic acid. So you have the R prime protonated first, and then didn't we were talking about this primary or secondary, primary or tertiary? Didn't we talk about this today?
Yesterday.
It's also on today's table, right? So okay, it depends on what you are. If this side is primary, secondary. Today's note we said it's going to do SN2. So ROH is going to attack here. It's going to do SN2 on primary. That's what we went today. We clarify who to do. And then if this side is tertiary, it's going to be SN1 on this side. Because if it's tertiary, this leave and form OH and tertiary. And then another R prime OH will add on this. I went over the primary, I write the mechanism of this one in my notes. You ask somebody else, they will tell you which node it is.
So those ROHs, they are still just that CH3OH that we were using in the beginning. We just keep continuously reusing it because that's the ROH that we introduced earlier.
Yeah. So whichever ROH you introduced, it's let's say when you deprotonate it, don't you form a lot of ROH? It's flowing around. Are we good with this? Are people good with this?
I
Yeah.
guess like what, because when we did talk about this today,
Yeah.
it was in the context of a nucleophilic acid like HBr or like HI. But
HBr makes like a haloalkane, and then if you react it with a non-nucleophilic acid, it creates two alcohols.
Yeah.
oh, okay.
Does it require heat to create two alcohol from like an ether with a non-nucleic acid?
No. Ether, this one doesn't need heat. The one that doesn't need heat is the SN1 go to E1.
Okay.
Okay. Are we good?
No heat. Okay.
Are we good with this one?